Okay, today we'll talk about weight and balance. Weight and balance affects all aspects of flight, including takeoff roll, distance, obstacle clearance, stall characteristics, stability, landings, flights. Any aspect of flight is essentially impacted by weight and balance. Determining the weight and balance, we need to define a few terms. So let's first talk about zero empty weight. This is the weight of the airplane without any passengers, usable fuel, or baggage. And it includes the instruments and oil and unusable fuel. Okay, then we can talk about the zero fuel weight. This is with zero usable fuel, passengers, and everything else included. Empty weight, ramp weight is what the landing gear can hold. Gross weight is what the wings can support. And basically, the ramp weight is going to have a little excess of gasoline because when we taxi, we burn gas. So takeoff weight is going to be, like in our airplane, it's going to be 8 pounds less than ramp weight, so we can take off. And then we can talk about landing weight. Not a huge factor in our planes, but landing weight's the fuel that we burn. This is going to factor a little bit more into the large airlines. You'll see, emergency situations where right after takeoff they have an emergency and they can't land because they're above their landing weight, and so they have to dump some fuel or burn some fuel to get back down on the ground. Okay, so now that we've defined our weights, let's kind of conceptualize this through something that you might have seen before. And just a couple of balance terms here that we're going to talk about. So you can imagine a scale or a seesaw. And if I were to put 10 pounds on either side and put a fulcrum point in the middle, that we're going to call the center of gravity. And then put each plank 100 inches on either side. You can kind of imagine that, right? These two sides are completely in balance. Okay? So we measure the distance from each point in arm inches. And then the center of gravity is where if I was a giant and I could hold the plane at this point, it would balance. If I were to take this scale and put 10 pounds on each side and have one plank at 100 inches and one at 99 inches, what do you think would happen? Well, it would probably tilt just a little bit this way, but it would still be relatively balanced, right? What if I do the same thing to the other side? Put 100 inches over here. and 99 over here. What do you think it would do? Well, it would go a little bit to this side, but it would still be relatively balanced. And so with that, we have a range than our CG. And then I can mathematically prove that by multiply 10 times 100, I get 1,000. If I multiply 10 times 99, I get 999. So I can mathematically prove that these sides are going to be a little bit off balance, but they're still within the range. So we have the weight over here. We have the arm that is measured in inches at all levels. And then we have what we call the moment. And the moment is the weight times the arm. And we call this, the moment is measured in pound inches. Okay? So we talked about the CG, talked about the CG range, talked about the weights, talked about the moments, and the arm. Does all make sense? Fantastic. Now let's apply this to the airplane. I have our airplane here. And I'm sitting right here. And you're sitting right here. And let's say we both weigh 200 pounds. 200 plus 200 equals 400. We would be sitting in the cockpit, and we need to know where to measure that from. So in the Archer, what we call the datum, an imaginary line from which all measurements are taken from, is at the front of the plane. So if I measured from the datum back to the cockpit, that would be 70 inches. And so this place where we were at would be called the station, and it would be called Station 70. And then we would multiply 70 times 400, and we'd get 28,000. That would be our pound moment for this station. Now what if we each had a bag that weighed 50 pounds each? Okay, if we each had a bag, and let's just say this is, 100 inches back, this station would be called Station 100. Okay, and then we'd multiply 100 times 100, and we get 10,000. Okay, so the pound moments, pound inches in moments for this would be 10,000. And how we actually get our weight and balance is we measure up all the weights and take all the moments, and we divide the weights into the moments, and then we make sure that that's within the CG, center of gravity range, and then we can know whether our airplane is inherently stable or not. That being said, what if we want to move some weight around? Let's just say that we wanted to introduce 100 pounds from station 30 to station 120. Formula is going to be weight shifted. Over total weight equals total change in CG over the distance the weight shifted. And for this example, our total weight is going to be 8,000, and our weight to be shifted is going to be 100 pounds. And we are trying to move this from station 30 to station 150. I'm sorry, from station 150 to station 30. So effectively what we're doing is 150 inches away from the datum, we're moving it closer to the cockpit up to the other storage area at station 30. So how we do this is we take the weight shifted, which is going to be 100, total weight, which is going to be 1,000, and oh yes, our original CG is going to be 77. Okay, and so then we take the distance shifted, which is 150, and we're subtracting that 30, and that equals 120. We can cross multiply to get 12,000, and then we're going to divide that by 8,000 to get 1.5. We add the 1.5 to the original CG, and we get 78.5. This is our new CG. We'll confirm that that's within our range, and we'll either make the flight or we won't. Now, what if we want to find out how far we can move something or how much weight we can move? Or what if we're out of CG and we want to get back in CG? Okay, so right now our weight is going to be 7,800. Our current CG is 81.5, and the max CG limit is going to be 8.5. So we're out by 1 inch. So what we do is what we're trying to solve for is the weight to be shifted. And we're going to take that over 7,800, which is our current weight. And then over here, we have the distance we need to move, which we figured out was 1 inch. Do that. And then we're going to talk about how much we're going to move the station. So we're going to move things from the back to the front, because that's going to give us a better CG. So 100, we're going from station 150 to station 30, and that's going to be 120. And we're going to cross multiply 7,800 times 1 is 1, and then we divide by 120, which is going to give us, let me see here, 65. So we need to move 65 pounds from 150 station to 30, and that will move our center of gravity the inch forward that we need to successfully have our flight. Okay, now let's talk about weight added. So to add weight, let's talk about our scenario. Our total weight is going to be 6,800. We want to add 140 pounds to station 80. I'm sorry, to station 150. So 140 pounds. And we want to add this to station 150, and our CG is 80. So let's see what our added weight will do to our center of gravity. So we're going to do the added weight up here, which is going to be 140. And then our total weight is going to be 6,800. And this is what we're solving for, UCG. And we're going to take 150 inches is our station, which we're adding to, and we're going to subtract 80 from that, which is our current CG. That is going to give us 70. We're going to cross multiply to 140, which is going to give us 9,800. And then we divide that by 9,800, divide that by 6,800. That gives us 1.44. 1.5, and we'll add that to 80, equalizing 81.5. So that's our new CG, and we'll make sure that's in range. Okay, and what if we want to remove weight? We have a aircraft that total weight is 6,100. We have our current CG of 80. We want to add or subtract 100 pounds from station 150. So what we're going to do is have our subtracted weight. We have to subtract this weight. I messed the last one up. You gotta add that poundage to the other one, so we're actually off by a little bit, but I'll go back to that in a second. 6,100 minus 100 to get our new weight, and get our new CG. And so we're going to take the station that it's subtracting from minus the station, which is going to be 70. We're going to cross multiply, getting us 7,000. We're going to divide that by 6,000, and that's going to get us 1.2. Since we're going forward in this equation, we're going to subtract 1.2 from 80, and then we're going to be left with 78.8. Okay, and those are the basics of weight and balance. We'll go ahead and work through one all the way through, but hopefully that gives you a broad overview.